Alright, chemistry. We're moving on to our first actual lesson in chemistry, and this is on elements and the basic atom. So an element is pure matter that cannot be divided into simpler substances. An atom is the smallest piece of an element. When you cut an element as far as you can, you have an atom of the element. There are 90 naturally occurring elements plus another roughly 28 that are created by scientists in labs. All matter in the universe is made of these 90 elements. Below are 5 examples of naturally occurring elements. Carbon, which can take many forms including diamond. Gold, which has been known of for thousands of years, but the idea that it's an element was not known. Neon, which is a gas, a noble gas. Uranium, which is the largest element, and mercury. Just as the 26 letters of the English alphabet can be arranged to make millions of words, the 90 elements can be arranged and combined to make millions of different substances called compounds. A compound is a substance containing 2 or more different elements. There are up to 70 million substances on Earth. Water, consisting of the elements hydrogen and oxygen, is the most common compound on Earth. There are basic divisions of the periodic table, and here's the periodic table. It's a list of all the elements in the universe. The periodic table is the centerpiece of the study of chemistry. And there you see some of the divisions of the periodic table that we will be referring to. Eventually you'll learn these without trying to memorize them. But the 2 major divisions on the periodic table are metals, which include alkali, alkaline earth, transition, and other metals, and nonmetals. Over on the right-hand side, those would include the halogens, the noble gases. Metalloids we don't really talk about. They're kind of like a border between the metals and the nonmetals. Although the nonmetals take up a very small part of the periodic table, they really are the most important in a sense because they're what all your body and all living organisms are made of. And we call those first 2 columns and the last 6 columns the representative elements or the main group elements. An atom is the smallest piece of an element that there is. If you cut an atom of gold or iron in half, you will no longer have gold or iron. An atom consists of 3 components. The protons, which are positive charges. Neutrons are neutral charges, they have no charge. And electrons are negative charges. Electrical force is the single most important factor in all of chemistry. The key point about electrical force is that positive protons attract electrons and electrons attract protons. Protons repel, push away other protons, and electrons repel, that is, push away other electrons. So previously we said that similar charges repel and different charges attract each other. These are referred to as coulombic forces. So there's the formula for a coulombic force. What it's saying is that if you take the 2 charges and multiply them together, that's Q1 times Q2, then divide by the distance between them squared, and then multiply by a number called Coulomb's constant, you will get the force between, say, an electron and a proton, or the repulsive force between 2 electrons. And almost everything that happens in chemistry is the result of Coulomb forces. So here's a numeric example. What is the Coulombic attractive force between a proton? And there you see the force. You're never going to be asked really to deal with that number, but occasionally we may just run an example like this. And an electron. Notice that the proton and electron have equal and opposite charges on them. And then the distance between them is 0.71 nanometers. So there's the equation. So if you plug in the numbers, it looks like this. 8.99 times 10 to the 9th is Coulomb's constant. Then you see the two charges up on the top, and then down on the bottom is the distance between them. Remember, that's nanometers, so it's 10 to the minus 9 meters, and you square that. And then you go ahead and crunch the numbers on that. I might give you one of these just to practice your scientific notation calculations, but not on a test. And there's the exponents. You add them on the top and subtract them on the bottom. And there you get the answer right there, 4.6 times 10 to the negative 10th coulombs. So a proton is the positively charged part of an atom. We assign a charge of +1. We don't use that scientific notation number you just saw. We just simply call it a +1. And we say that the mass is 1 atomic mass unit. For an electron, that's a negatively charged part, and we say that it has a charge of -1, the opposite of a proton. And it's so light that we say it has 0 mass. It's 0 atomic mass units. And we'll define atomic mass units shortly. And finally, a neutron is neutral. It has no charge. So we assign it a charge of 0, but it does have a mass of 1 atomic mass unit, the same as a proton. And using these simple approximations for mass and charge, it's good enough. We can do all the chemistry we need to do using those numbers. Okay, so here's an atom, a basic model of an atom. It's the old school model that was invented 100 years ago. So it has orbitals. Orbitals, also called shells, are energy levels where electrons move around the nucleus. Okay, they're not actually a thing, they are just a space around the atom. Okay, protons are the positively charged particles in the nucleus. Neutrons are the neutral charges. Electrons are what travel around the orbitals, so the protons and neutrons stay in the center, in the nucleus. Finally, an important term is a valence orbital is the outer orbital of an atom, because helium has only one orbital. This is the valence orbital. This is a helium atom, by the way. Valence electrons are the electrons in the valence orbital. It is valence electrons that form chemical bonds. So we'll talk about that later. Okay. Chemical reactions create new substances by rearranging atoms into new compounds through a chemical reaction. So there's a simple example to create water. Its 2 hydrogen molecules plus 1 oxygen molecule will produce 2 water molecules. Water is comprised of 2 atoms of hydrogen and 1 atom of oxygen. A chemical change occurs when the atoms combine to form a structure called a molecule, in this case. But generally speaking, it's anytime atoms get rearranged from one form to another, that is a chemical reaction. Because water is made up of more than one different kind of element, it is referred to as a compound. So there you see we kind of draw a diagram that's called a particulate diagram. So you have 2 hydrogen molecules. Each molecule has 2 hydrogen atoms, 1 oxygen molecule with 2 oxygen atoms, and that produces 2 water molecules. Physical changes determine whether a particular substance is a solid, liquid, or gas. These are called states or phases of matter. There are 3 states of matter: solid, liquid, and gas. Solid molecules are held firmly together. In the case of water, we would call this ice. Liquid, the molecules touch each other but can move around each other. So liquid water splashes around in a cup. And gas, the molecules have enough energy to separate from each other and move upward against gravity. A nuclear reaction is one where the number of protons or neutrons in the nucleus change. Number of protons changes. If number of protons changes, elements are defined by their number of protons. This is a key point. If a proton is added or removed from an oxygen atom, the atom will no longer be oxygen. Okay, it'll be some other element. The number of neutrons change. The number of neutrons in 2 atoms of the same element can be different. These are called isotopes, and we'll be introduced to that term a little bit later in more detail. AP chemistry deals with chemical and physical changes, but not nuclear changes. All right, and that takes care of this lesson on the basic atom and elements.